Hi, Spring fans. So in today's installment, we're going to look at JTA. Now, JTA is the Java Transaction API. It's a way of managing distributed transactions across transactional resources. It is the client-side middleware, the client-side binding for what's called the Java Transaction API, or rather, it's the client-side binding for what's called the XOpen protocol. Now, the XOpen protocol is a protocol that allows different transactional resources to enlist in a transaction by a client, initiated by a client, and then prepare for that transaction, and then upon the sort of signal to then commit or roll back. This requires necessarily it requires state that's kept external to these transactional resources. So you've got the cost of synchronizing two different otherwise sort of independently moving, independently advancing entities in lockstep, and you've got this third resource that you have to add to the transaction. So as a result, distributed transactions can be very slow. But that said, there are a lot of applications that are sort of built yesteryear, and they tend to take advantage of these distributed transactions. And people wonder about whether it's easy enough to use this inside of a Spring application. So certainly it is. I don't recommend it though. There are a lot of ways to solve the problem of getting two different resources, two different separate independently deployed resources to agree upon distributed state that are more elegant than JTA. But if you happen to have an app that's using JTA, that's probably not the answer you want to hear. So what I'm going to show you how to do today is how to take advantage of JTA as it's supported inside of Spring, and in Spring Boot in particular. So we're going to look at two examples, two very quick examples. The first example will be a Spring Boot application that works with a data source and a message queue. So we're going to say XADSMQ, and we're going to use Spring support for building web applications. We use H2, the in-memory embedded SQL database. We're going to use ActiveMQ, which is a message broker. We use JDBC support, and then that'll be the beginnings of the application. But we need, in order for this to be a JTA application, we need JTA. Now, this is where I think a lot of people get confused. JTA is a specification. It describes an API. The API requires an implementation. When people think about that implementation, they typically think about consuming what is called a user transaction object. And so in the JTA specification, there are two key objects. A user transaction is meant to be a sort of client-side representation of a transaction manager that is provided by the JTA implementation. The client-side representation has your sort of everyday methods for managing the body of work or the unit of work in a distributed transaction, the start, stop, commit, rollback, that kind of stuff. But this is not all that most transaction managers are capable of. Indeed, most transaction managers also can go a step further, and they can do things like transaction initialization and resumption and suspension, right? So you can do more than what's exposed on that user transaction interface. Those extra capabilities are often found in the JTA spec transaction manager interface. Now this is a separate interface. In Java EE, the application server must provide a user transaction implementation under a well-known JNDA location. There is no requirement to provide a well-known transaction manager implementation, but in practice, most application servers do provide an implementation. It's just not under the same portable sort of JNDI location. But Spring knows about all the common locations, and it will take advantage of both. The one that has the most power, it'll use that if it can, right? So what we're going to do is we're going to use our own standalone JTA implementation. Again, Spring doesn't care if the beans that it needs, the objects of type transaction manager and of type user transaction, come from a JNDI context in an application server, or if they come from a sort of standalone JTA implementation that Spring Boot automatically configures for us. What we're going to do is we're going to configure JTA in our Spring Boot application, or rather we're going to let Spring Boot configure JTA for us, right? If we ran Spring and the Spring Boot application inside of an application server, a Java EE application server, the minority use case to be sure, but just in case that is your use case, this will just automatically work. You don't even need a standalone implementation. It'll detect the JNDI types on the application server, and it'll configure it'll wrap and adapt those transactional resources if they implement the required XA interfaces, right? So there's a XA resource interface inside of JTA. And in the JMS world, the Java API for messaging, there's the XA connection factory, which is a JMS connection factory that implements the XA resource contract. And then in the JDBC world, there's an XA data source, which is a data source that implements the XA contract. So as long as you're using JNDI provisioned connection factories and message queues and so on, then the Spring Boot auto configuration will use the JTA transaction manager as it's bound inside of the JNDI directory in your application server. In our case, though, we're not using a Java application server. We're just using a local sort of embedded Spring Boot application. So we're going to have Spring Boot auto configure a JTA implementation for us. And Spring Boot out of the box supports three very popular, very widely used choices here: Atomicos and Bitronics, both of which are Apache 2 licensed, open source, etc. They're both actually, interestingly, both they originated from Belgium. Little bit of trivia there. Atomicos is, I think we're going to use that, not because it's better or worse or anything, but because it starts with A. One thing you should know about Atomicos is that it also has a premier sort of level, right? So you can use the open source JTA stuff, and that works just fine. But if you want to go beyond JTA and to handle some more interesting corner cases in the JTA world, the folks behind Atomicos sell, supported enterprise grade extras. Okay. All right. So we're going to hit generate, and because this is Spring Boot, both our data source and our message queue will be automatically configured for us. In fact, they'll be embedded. There's no reason we couldn't specify properties that point to standalone, separate, data sources and message queues running out of process. But in our case, we don't really need to. We're just trying to get an example going. So they're going to be automatically created for us and configured for us in the Spring Boot application. We're going to go here. We're going to create a application that has a REST controller. So we'll say public static class XA REST controller. Okay, maybe XA API REST controller. And we're going to make this a REST controller like so. And in the REST controller, we're going to have a write method that takes as its payload a map of string, and we'll call that the payload. And this will just be a wrapper for a JSON object that'll be sent from the client. And we want to make this a @post mapping, so somebody's going to write to the message queue here. And we want to be able to throw an exception if something should go wrong. So here we're going to say request param optional, so either it's going to be there or it won't be. And if it's not there, then we want to be able to handle that case gracefully without a lot of if null checks. Okay, so what we're going to do is we're going to use the auto-configured JMS template. Okay, this is the client-side interface for working with JMS, and we're going to use the automatically configured JDBC template. Okay, provide those in the constructor here. Spring Boot automatically configures them. We're just injecting them to use them, and we're going to send messages. What we're going to do is we're going to send a message to a JMS destination here called. We'll just give it a variable name here to make it easier to remember. So we're going to call it messages, and we will write the messages to the database, and we'll write it to a message queue, and if we need to. So, but let's see. We're going to say this .jdbc template .execute insert into message ID and we're going to call it ID, and we're going to call it message, I guess. That'll be fine. Values, question mark, and we'll pass in a ID here, and the ID we want to record for later, so we'll say ID equals UUID dot random string dot toString. Okay, and we'll pass in a message here, and the message will be derived from the payload of the JSON body, so we'll say request or payload dot get name string message equals hello name. Okay, so there's the message that we're going to send update will work. There we go. And we want to send a message via the JMS template as well. So we'll say this dot JMS template dot convert and send. And what we're going to do is we're going to send a message to a destination called destination. And the message will be this, right? There we go. So we're going to send the message, we're going to write it to the database, and then we're going to send an event or publish a message into the broker where some other component running in the same node or running in another node could then receive it. And so let's do that now as well. Let's create another component here, a JMS listener, public static class message notification listener, and here we'll make this a service, and we'll just declaratively respond to on new message, right? And the payload will be the message itself, or maybe we could just write the ID, right? We can actually just send the ID of the record that was written, the claim check pattern there. As long as we have the ID, we can look it up again later. So string ID, and we're going to use a nice feature here in one of the more recent versions of Spring, which is a JMS listener annotation. I think this is Spring Framework 4.2, but memory might be failing here. And all I'm going to do is I'm going to print out the new message. So message ID. Okay. Now this JMS listener annotation is a convenient syntax shortcut for creating a message listener container. So again, if you've ever used a message listener container or for message-driven beans, this is just far more convenient. There's similar support inside of Spring AMQP for the AMQP listeners. There's similar support in other Spring projects, but suffice it to say, we've got everything we need there. Okay, so I think the last thing that would be very convenient to look at is a way to enumerate any messages in the database. Wouldn't that be useful? That might be useful. Let's see about that. So we're going to say get mapping public, and we're going to create a collection of maps of strings messages, or we're going to just call it read. Okay, and we'll say return this dot JDBC template dot query select all from message new row mapper. Okay, so we're just creating a classic JDBC template query, and we're going to say for every result that comes back, let's create a map, a hash map here, and we're going to put some fields in there. We're going to say ID equals our result set dot get string ID, and we'll say result set dot get string message. Okay, there's this. Now, of course, you're looking at this as I am and seeing lots of opportunities to remove dead code, so let's get rid of that. We don't need it. This can be a lambda. That's nice as well, so good. And there we go. So that's our read endpoint, right? So the final thing that we need to care about is rolling back the transaction if we're, to demonstrate that this does as we expect. So let's make this a transactional endpoint. So we're going to say @transactional using Spring's @transactional annotation. There, you might have seen javix.transaction.transactional. That's a new feature in Java E7, released in 2013. Whereas the Spring transactional annotation covers a superset of the support there, and of course it's been around for 12 years or so, 10 years at least. So we'll say if rollback dot or else is equal to false, throw new runtime exception. Okay, couldn't write the message. Okay, there we are. So there's our messages. We've written them, and that should do. Let's go ahead and see if that works. Let's go ahead and configure this. Now again, what's going to happen is it's going to create a JMS connection factory and a JDBC data source. Spring is going to see that both beans implement the XA resource type somewhere along the line, so that'll make them a candidate for enlistment in the XA transaction. The auto configuration will wrap them and adapt them for the atomicos types. So we'll actually, the data source that gets created will actually be a atomicos data source that wraps our XA data source, and there'll be an atomicos connection factory that wraps our XA connection factory. Now what you see on the console here is the polar, the sort of heartbeat that gets created by the message listener container, cycling all the time. So let's see here. Terminal. And what data did we say we're going to write? We said that we're going to write based on the name, right? So let's go to the console here. And we're going to send a curl with the name equals spring fans. It's going to have content type equals application JSON. And we're going to send it to this endpoint. We're not going to trigger an exception yet. So we're going to send it to there. We don't have the table, right? So we need that table. My mistake. So we'll go here, create a table in the schema here. Schema schema.sql, create table message. Okay, and it will be ID varchar 255 not null unique, and message varchar 255 not null. Okay, try that again. Good. Okay, write localhost. There's the read. We've got one message. Let's do another one just to confirm. So we're going to send now hello spring fans, hello again spring fans, send. We've got now two messages, right? There's this one here and the hello spring fans. Now let's trigger an exception, right? And if we look on the console also here, we should see message ID only twice, right? So there it is. It says 2 matches right there, right? 2 matches. That means it's the message has been sent twice, and we see on the console that we see in the output of the REST API that it's been written to the database twice. So everything's fine. Now exception, or rollback rather, equals true, right? Isn't that what we said? So rollback is the parameter here. Yep, rollback is equal to true. It's going to throw an exception. Voila. If we go to our endpoint, we should see nothing else, right? It didn't get written after all. And if we look on the console in the JMS listener here, still just 2 matches, right? You can't see a third one. So even though we threw the exception after seemingly both the JMS template and the JBC template had done their work, the unit of work hadn't been committed yet, and it was rolled back for us automatically. So we've used Atomicals to correctly enlist both transactional resources and to roll back the commit as though they never happened, creating a consistent state from the outside. All right, so this is a simple example. Here we've got an unambiguous data source and an unambiguous connection factory. What if we had 2 different data sources, right? This would require a little bit more work. So let's take a look at that as an example. We'll close this off. Close this. And go to start.spring.io. Now, let's say we wanted to create a 2 data source example, not using any kind of JMS, just 2 different data sources. We'll use H2 again. We're going to use JTA, so we'll use Atomicals. We'll use the web support again. We need JDBC support. And I think that will do. Now in this example, what we have to do is we have to, first of all, Spring Boot is the auto configuration. A lot of that is optimized for if we have a in-memory database on the class path, then it'll automatically create a data source for us if we don't provide our own data source. And it certainly doesn't do a great job if we have more than 1 data source. So let's go ahead and create 2 data sources ourselves here. We need to do this a little bit more manually. So in our code, we have a few things that we need to configure. First of all, what we want to do is we want to configure the data sources themselves, right? So we'll say bean data source A, okay, bean data source B, data source B, okay. Okay, there's this, and A, and we need to provide a implementation of the JDBC data source type that we want. In this case, I'm going to use the H2 data source type, right? So JDBC data source, that's this one right here. This is on the class path, but right now the auto-configured H2 driver is runtime only, so let's make it compile time so we can see the type. And we'll say new equals this, set URL equals, what do we want? What is the URL for that? And it's H2 in-memory string examples. Good. Quick start, it's fine. We'll use this. And I don't want this to be the same file each time, so I'll just localize it, and we'll override the string here. So I'll say b plus a random string uid dot random dot. There we go. Okay. Actually, it'll probably be fine if we just leave it like that. Okay, so we're going to create an in-memory database that is named by the data source. It'll be called A and B. The username will be SA. The password is empty. Turn that like so. Okay, so we've got now two different data sources. We need to initialize the data, right? So again, these are two different data sources. This one could be MySQL, one could be Postgres. It just happens that they're both data sources that are of the same type in this case, but they don't need to be, right? One could be Oracle, one could be Postgres. Who cares? What we want to do is we want to initialize the data in both of them, right? We don't want Spring Boot to run its own initializer. We want to create our own initializer that contributes custom data. Maybe one will have a table full of pets, objects with names, and another one will have a table full of messages, the same idea as before. So we'll create a bean of type data source initializer, a init. We're going to return init, and we need to provide a data source, the data source that we need here. So there's this. Okay, we're going to use A, call it A as well, and we'll just create that init method. Good. And we'll create a data source initializer. Now, data source initializer is a convenient type in Spring itself that you can use just for that. You can use to initialize databases. So here is our data source, and we're going to create a database populator, and we're going to use a resource database populator, and the resource database populator is going to need a new class path resource, and we're going to say name dot of a SQL, dot SQL, and then that'll do. I think that'll give us a lot. I think right there, right? So good. Now we need to run two of these init methods. So one for the A database and another one for the B database. Okay. B. Good. There we are. There's the two data sources and the two initializers. That should be enough. We need to disable our default initializer, right? And we need to create some schema here as before. So we'll create two different tables, one called a.sql. A.sql contains our table of pets. Okay, and nicknames. Good. So there's this, and b.sql will contain the message table, and same as before, we'll just write a message to the database. Okay, now then, with that underway, we have 2 initializers and 2 data sources. You might have other things you want to configure on these data sources, right? And you want to do that in the properties, and you can still do that. Just because we're configuring the base object and not in code here doesn't mean you couldn't add configuration properties. Prefix equals A. So that way, if you went to your configuration file, or rather, that would be B, I guess. If you went to your configuration file, both would take properties, right? You could say any property that the JDBC data source type here supports would be then dereferenceable. So a.url, a. whatever. I'm just doing it in code because it's a simple example, but take note. You could do that, absolutely. All right, so we've got 2 different data sources. We've got 2 different initializers. Let's go ahead and create a REST endpoint. Just to, we want to write data to both endpoints, to both databases. So we're going to say public static class. Let's get rid of this thing here. Close that. XA API REST controller. I'll call this a REST controller. Public void right. And what do we want to do? We want to send a post, and just like last time, we want this to be transactional, right? So we'll say at transactional, and the request body will be just like last time, a map of string payload. Okay, and we're going to optionally throw an exception if there is a parameter there. So we'll say optional of Boolean rollback. Okay, and now we need to use the different data sources here to create JDBC JDBC templates. We don't have 2 different JDBC templates, so we need to create them ourselves. So we'll say JDBC template A and B. Okay, I'll provide those 2 in terms of data sources here. So we'll provide the 2 different data sources here in the constructor, and just initialize them. New JDBC template A, new JDBC template B, and voila. Okay, now we can do our work. So the A database has the table for the pets. So we'll say this dot A dot execute, or update rather, insert into pet ID nickname values question mark, and we'll take the name here. So string name equals payload dot get name, string message equals hello name, and we're going to write the name into the database here. We'll say that we have an ID, UUID dot to string, a random string. Okay, name, there's this, and then in the B database we want to say insert into message, and we'll pass in this message here, and voila. Okay, so that'll be fine. And then of course, just as with last time, I want to say if rollback dot or else. So if it's false or if it's not there, then we won't bother. But if it is there, then, and if it's true, then we're going to throw a runtime exception. Couldn't write the data to the databases. Okay, and voila. Okay, that should do it. It's a transactional endpoint just as before, except now instead of using JMS and JDBC, we're using just JDBC. We've got a payload. We're going to send JSON of type name, or with a value of type name. The a.SQL is for pets. The b.SQL is for messages. We should have some way to confirm that this was done, shouldn't we? So let's create 2 endpoints here to read the data. So we'll say 2 endpoints of type collection of map of string pets. Okay, and we'll say at get mapping pets. We're gonna simply return this dot a dot query select all from pet new row mapper, and we don't even need that, do we? We can just make it a little simpler, just a collection of strings. Okay. Return result set dot get string nickname. Perfect for lambda. Okay. There we are. There's our simple pets endpoint, and we'll create another one for messages here. Message, and get the message. All right, that should allow us to confirm that everything is working. You know, we'll have the visible side effects on the outside, so we can, you know, we can see that only what we expect to have happened has actually happened. Now, what is wrong? Our JDBC URL isn't correct for the file type, so we can say just store it in the local file system in the same directory as the one that's running this process. Okay, it's up and running. So curl a name, hello spring fans, same as before, except slightly different. We're not going to roll this one back, not yet anyway. Right, insert into message, table message not found. That's because I forgot to make this use the B data source. Remember, they're two different things. So we'll restart again, or restart. Delete the data from, okay. Here. Okay. Table message not found. A init. Oh, son of a gun. B. Now, to be more explicit, you might have used a qualifier. I could have used a qualifier like that, but in this case, the name will automatically, you know, the name of the variable will disambiguate. Okay. That way, if I had used a qualifier, then it wouldn't matter what the name of the variable is. This is exactly the kind of issue you want to avoid. And of course, now this is a problem. So armrf, sorry, here. Get rid of all this stuff here. Goodbye. Hooray. Okay, good. So let's send that. It's working. Good. Localhost. Pets. Got that. And messages. Got that. Okay, so our messages and our pets are there as we expect. Everything's fine. Let's go ahead and send another message just to prove that it works again. Hello again, spring fans. And again. Okay, so there's that. There's that. Now let's throw an exception. So we're going to send spring fans again, but this time we'll say rollback equals true. And that's the parameter that we used, right? Yep, rollback. So here we go. Ready? 1, 2, 3, go. Throw an exception. We should only see. Oops. Did I forget to make this transactional? Ah, it's not transactional. It is transactional, but what I forgot to do was wrap the data sources, right? So this is what we need to do. This is actually the last missing piece here. So we have our two data sources. We've initialized the data correctly. The transaction manager that we're using is transactional. It's a JTA transaction manager, but it's not aware of these transactional resources. So the final thing that we need to do is to automatically initialize our data sources and wrap them. And we can do that by injecting here a XA data source wrapper into the constructor of our application. And here we say wrapper.wrap data source equals this. Throw an exception. And do the same thing here. Now these data sources need to return, well, we can return the type and that should be okay. So there's this. There we go. So we're returning a data source, we're wrapping the data source with a wrapper, and then everything else is basically as it was. Let's go ahead and restart. Okay, reset both of them. Now, here we go. Let's try this again. This time we've done the right thing. We've enlisted both data sources in the transaction by using the data source wrapper interface, the implementation of which is provided by the auto configuration. As you can imagine, there are 3 different implementations of this type. There's a Atomicals one, Bitronics one, and Ariana one, right? So we're using the one that's provided by our implementation. We're going to send spring fans. We're not going to roll it back. If we go here, they're both there, the message and the pet, or the user, I guess. Okay. Pets is probably a poor name for spring fans. Okay, so there's that. Now let's roll back the exception. Okay, so exception, or rollback equals, rather, rollback equals true, throws an exception, 1 message in the messages endpoint, 1 message in the pets endpoint. So there we go. It did not write that second registered message, right? We wrote it to the endpoint. It certainly got processed, but then we threw an exception, so the unit of work that wrapped both of those was undone. All right, so in this installment of Spring Tips, we've looked at how to use JTA, and we've looked at how the underlying abstraction plugs in the various relevant pieces from the JTA API for you, be it inside of a Java EE application server or in a standalone embedded kind of fashion. We've also looked at how to work with more than one data source, which I think is a very common use case. Now, that said, I do really want to underscore that this is not a great fit for sort of modern applications. It creates a single point of failure. It's not going to be what you want if you're trying to deal with multiple microservices, none of which are going to implement the XOpen protocol anyway. And it requires a file system, and I do mean a java.io.file, right? Transaction managers need a durable file, java.io.file, in order to do their work, which is kind of a naive assumption because in the world of the cloud, you can't really take for granted the presence or availability of a file. So it'd be nicer if there was some sort of other API besides the java.io.file, which is itself final, right? So you could use some sort of other durable IO store, right? All right, thank you so much for following and for tuning in. We'll see you around next time.